Gotta hold it.
Excuse me?
The camera does not know you, son.
What the flick?
Alright, this is gonna be very.
I know.
We should go back. That person's outside.
Rainy tech.
I
Like I said, that's and room 4.
Okay.
Okay, here we go.
Yeah.
Let's start at the beginning, children. The first graph you have on that paper is the parent function of the absolute value of x. You should be able to graph that. I will tell you, the key to what we're doing for tomorrow is that the parent function of the absolute value of x is a v. It starts at the origin and it splits diagonally. It goes over one, up one, infinitely. Okay, you just need to draw this. I guess I will just draw it. You have this going through here, you're drawing it with a straight line, this going. That is the parent function of the absolute value of x. Did Lucy not give it to you?
I did not get
Are
it.
you trying to make David fail?
Lucy's selling.
I only got one.
He's selling David.
How does everybody else get two, David, they can only get one? Makes 0 sense.
David, are you
David
okay?
and Goofy got one.
Whatever.
David actually had two. I won.
Okay, now, here is that, so there's graph number 1. Graph number 2. Okay, I need to do this all at once, but I think my thing didn't work because I did too much all at once. Graph number 2, does that
Yes.
make sense?
Yes.
If you end up with a number outside of that absolute value sign to the right of it, okay, that just shifts your parent graph. Our parent one was this. This number, if it's out there, not inside that, not in front of it, just out there, just shifts it up and down. So this is just going to be the same exact graph, except it's down 3 places. So it's that. Okay, that should not be too confusing to you. Okay, right?
Yes.
Wait.
Yes.
Right?
See, right there.
Always.
Now, the next one. Oh, sorry. The next one I gotta look at. I'm gonna try and copy it all at once here. Ready? The next one would be this. If you have, please work.
Yay.
Oh.
Oh.
If you have this, if there's a number in front, a multiplication thing in front of the absolute value, what does it do? Do you remember? David?
Who's it? Vertically.
Nope.
Oh.
If there's a number in front, like this, it does what, Sam?
Shrink.
It shrinks it. It makes it narrower, okay? This one is going to be narrower, okay? Since there's no number here, it starts at the origin again, because that's the thing that moves it up and down, left and right, well, up and down, not left and right. But it just shrinks it. Now, if you remember, and this is something that you can think about, okay? This is actually the slope of that graph. What is slope? Slope is a fraction, it's 3 over 1, it is 1 over 3 up. Is it over width, over height, height over? Huh? Yeah,
Yes, sir.
so, and that's what's gonna do, look, the point is gonna be here, and the point is gonna be reflected on that line, the same thing. You could draw a table, but you don't need to, because rather than it being that wide thing, it shrinks it, narrows the opening, and that's the slope. It goes over 1, up 3. So this is your graph of that.
No, it's so cool.
That's
Okay.
crazy.
It's crazy.
What part? Remember when we did y equals 2x plus 5? And the number in front of the x is the slope. The slope is 2 over 1. Okay, that's the same thing here. Over 1, up 2. This is how wide it is, that's how high it is. Height over width.
Is the origin moving?
No.
What's moving?
Now, if, hold on a second, here's where you gotta focus. If I would put a -3 there like I had, I get the same width of the graph. It's just that that graph would be shifted down 3 just like it did before. If it was a +3, it would be +3 right there.
Yo.
That's sick. That's so cool.
So, but it's not, so we do this. Get rid of this. Okay, this one here. If the absolute value is negative, we talked about that, a negative makes it a reflection about the x-axis. That means the parent graph was like this. If it's negative, it just is the same thing, except it's down here.
Whoa. What? That's crazy.
It is a reflection there. That's what a negative thing. We'll put all this together in a bit. But let me pause for some reflection here. Do one of these. Watch. If I were to go back to this one and put a negative in front of it, it's going to be this graph, except it's a reflection.
Whoa.
Sorry, I didn't get it. Sorry, I missed it. Wait, let me get back. Except it would be a reflection and be tipped. Same starting place, just that it's upside down. Because eventually, well, today, at some point later on, we will actually put all of this together. Now, so here, let's put this together. Here is how you have to start. This is what I need you to think. The first step in always is to figure out where the vertex of your graph is going to be. Where is the pointy going to be? Okay, and this one, the pointy Kavarik, who wasn't even here yesterday, is where? On the y-axis, because of this. This shifts the whole graph down 5. The thing that moves it left or right is if there is a number inside the absolute value, a plus or minus something inside, and we haven't done that yet. So we haven't shifted left or right, it's just up and down. The vertex of this graph will be right there. It's going to be at +5. Secondly, the number in front of the absolute value is negative, so it's going to be upside down. It's a reflection about that point. And this 2 is the slope, which means from this point, it's going over 1 and down 2. Over 1, down 2, because if it wouldn't have been negative, it would have been up 2 over 1. Whatever, it has to come down, so I have to pick that way for my slope. The number in front of the x is 2 over 1. 2 over 1. 2 up or down over 1.
I thought because it was negative, you flipped it.
I did flip it. Otherwise, it would have gone this way.
down.
It is
So
going,
down because it's negative.
I'm not silly sussers. Like, actually,
if this negative would not have been there, it would have pointed up. Ooh.
Ooh.
Now, here we go. Next one deals with shifting left and right. So now we add on to that, if a number falls inside of the absolute value like this plus 1 moves it left and right. This number on the outside moves it up and down, this one moves it left or right. But the only problem with this is, yes, this goes down 6, but when it's inside the absolute value, you have to think opposite. Instead of this moving at one place, logically, you would think, Emily Robbins, that this 1 would move at one place to the right, but it isn't. It's opposite. It moves at one place left.
Yes.
So finding your starting point means this. The starting point is going to be down 6 over 1 to the left. Down 6 over 1 to the left. That is the vertex of that graph of that function. Okay? And then, no, there's no negative there, so it's going to open up like this. And there's no number out here, nor is there a number next to the x, so it's going to be the normal absolute value function. It's just going to slice it, just like a normal one, right through the middle of those triangles. It's just going to look like this. It's the normal width. It isn't shrunk, it isn't expanded, it's just that.
Yeah.
Let's go.
Oh no, it will all fall apart.
That's not true.
It will all fall apart next. Ready? Second sheet, that was all of them on this, right? So here you go. Putting it all together. I use putting it in terms of putting.
Wahaha.
Here we go. Let's see if I can cut both of these. I don't know what I can do. So here we go. I'm going to give you the whole thought process again from the get-go because it takes multitudes of things. So here we go. Here is your thought process. See, I will go super slow for this. Okay? Super slow. First thing you want to do is you think, find the vertex. Okay? And to find the vertex, first thing is you look at this number here. That tells you the vertex is down 6. And the number inside of that thing tells you it is what? Left or right 2? Left, because it's opposite. Down 6, left 2. So my vertex always starts at the origin. I have to go down to -6, left 2. That's where my vertex is. Stop me there if you didn't get that. You can always draw a table on this too, but I will tell you that will take you a long, extremely long time. Okay. After that, that's point number 1. Point number 2, is it a reflection? Which means, is it negative? No. So if it's not negative, you know it's going to open up like that.
Yeah.
Okay. Point number 3, okay, if there was no number here, this would just be the normal slice it right through the middle thing, but since there's a number there, if that is a whole number, it's going to shrink it. If it was actually a fraction, it would make it wide and kind of flatten it out. And then you just have to think, if there is a number, is there a number
Yes.
out I should say, is the absolute value multiplied by a number? And in this case, it is. That is your slope. Means make it a fraction. It's 2 over 1. 2 up, 1 over. And by the way, for absolute values, it's 1 over in both directions. In other words, it's going to go 2 up, 1 over this way, 2 up, 1 over that way. You keep going 2 up, 1 over, 2 up, 1 over, 2 up, 1 over. There is the graph of your absolute value function there.
Let's go.
Now, I am going to, at the risk of befuddling you even more, I will let you try this. See how far you get on that one without any help, and we'll see if we cannot make some sort of headway on this. Find the vertex first. Where is the point? It is shifted in both directions. It shifts in both directions. It is negative,
No.
and there is a slope. Are you done already, Carpard? How was Carpard this a whole day and was like, be that bad?
I'm done too.
Maybe he just got a lot more rest than the rest of us.
I'm not.
Can't be natural intelligence, can it?
What? Carter's done too. He's so speed.
Who feels relatively confident that they have
I
that?
know,
engine?
me. Call me.
Oh, I
Calling me is.
Mr.
I'll do it.
I think you feel it.
Carter Reichert, where is my vertex?
It's up 8 and then over -6.
My vertex, ladies and gentlemen, is, because this number here is the up or down, up 8. Do the opposite of what number that is, up 8 over 6 is right there. Who succeeded at least in that?
Great.
Not, please tell me what happened, Sam.
I went down 8.
You always think opposite of that number. Now, next thought is, there is a number outside of that absolute value sign, and it is negative, which means it's a reflection of the x-axis. So you know it's going to open up like this. And then the problem is it's a slope of 4, which isn't really that problem because it just means it goes up or down 4 and over 1. So down 4, 1, 2, 3, 4, over 1, down 4, over 1 this way. You can keep doing that. Down 4, over 1, down 4, over 1.
Like,
He's so intelligent.
Score?
100.
First try.
Stop me if that does not
Light or
heads or tails.
Like, no reaction.
180.
Now, you are going to, in order to practice this, there's a great IXL site there.
Yay!
Listen to me. Listen to me. If somebody comes up to me and says, what happens here? I don't know how far you'll get before they do this, but if they give you a problem that looks like this, no, right? If they give you a problem that looks like this, if they give you a problem that puts a number in front of the x, but it is in the absolute value sign, you will not be able to do it because that's not the same as the number being outside and it changes things dramatically. So we haven't covered that yet. I think you can probably get a long ways before they actually give you one. And when you do, come show me and we will talk and I'll tell you to ignore it and move away.
Do we stop there or just like?
I don't know how long it's gonna take you to get that.
Let's go, guys.
we don't know if you'll get it.
Let me
First record.
find.
Can I do IXL?
You're the best at
This is not how- The only other problem with that is I did not assign it.
My pencil is.
So let me assign it.
Come on, Greg.
It's gonna take me a minute to get it up there.
Did you say it was a stone post?